Well, hi, good morning. Thank you so much for joining me here on August 7th for another round with this equipment. Now, it's not really with the equipment. I'm down to a very, very simple thing here I'm having trouble with, which is determining the output strength of the little radio there, or any radio like this. So, the last video, which I had to start off with a warning watching it, I liken that whole experience to being out in the middle of a lake. You've fallen out of the boat, you're thrashing around in the water, and you can't get your feet on anything solid. So what's the solution there? Well, the solution is to get back to shore, for sure. And so get some solid ground under your feet you can stand on. So here in my shop, what that translates to is making a measurement of the power output of this little radio to start with. Right at the back of the radio with as little cabling as possible. So what I'm going to do here, and I can't find it at the moment, is I'm going to put a Y splitter on here. Why, you might ask? So I can put the dummy load into one leg of the splitter. Here it is. And the other leg's going to give me access to the center conductor, and I'm going to be able to measure this in various ways, and that's going to end the confusion. So it's a 50 ohm resistor right here, and a supposedly 50 ohm circuit here. That should deliver maximum power. Maximum power transfer should take place. Now, that should generate a certain voltage across this resistor. I should be able to measure that voltage with any one of a number of instruments. But the one I'm going to start with my oscilloscopes. Now, I discovered while I was flailing around in the water in the middle of the lake, trying not to drown, I discovered that the calibration output for this scope is no longer calibrated. At least that's the conclusion I'm at right now. That might change. But I also discovered the calibration output on this scope actually appears to be correct. Now, how did I come to that determination? Both these scopes show this to be correct, the output voltage here. And it also showed that both scopes are calibrated, unless all three things are wrong together. Unless that's what's really happening, which it's a matter of odds, isn't it? So I think that's probably not the case. I think the case is these things are calibrated properly now. So we can make a measurement on here of voltage, and we can measure just with a single lead. I'll grab one right now. A single lead, scope lead. I have it on ×1. Maybe we'll have to do this on ×10. Now all I'm going to do here, ground there, which came right off. So let's put this on first. Hopefully this is going to save me. I'm going to get a result here which makes some sense. How would he? Well, here's how it will make sense. The output of this is almost certainly between 3 and 4 watts out of the factory. 4 watts is the maximum power output allowed for these radios, and many of them do not even reach 4 watts, apparently. Some can be as low as 2 watts coming out of the factory, apparently. I bought this radio basically new in the box. It had never been put into service. This and another two more of the same, like, quite new radios. So I actually have 3 that I could rely on as being in factory condition and assume the output power is 4 watts, maybe a little less. Okay, so we're hooked up here. Now, another issue, put the squelch up, another issue here is the power supply I'm driving this radio with is a wall wart. Now it's a big guy and it promises to put out a fair bit of power. Judging from the panel lights, it's successful. The lights don't dim at all on here. 4 watts is not that big a deal, is it? Okay, so we've transmitted already. Let's take a look at the scope here. I'm just going to flip to the scope camera. I don't even have the scope turned on yet. Let's turn it on. Okay, so we're on channel 1. We're set to 5 volts and it's times 1. What are we going to see here? 5 volts times 1. Here we go. Nothing. That's 0.5 volts. Oh, that can't be it there. This is just a hum and stuff like that. I really got this on the times 10. This is the times 10 now. Well, it doesn't make any difference. Oh, something's going wrong here. If I'm on a different... Yeah, you know what's going on? I'm not on channel 1, I'm on channel 2 here. That's why that was happening. Okay. Channel 2. 5 volts per division. That's more like it. Definitely on 5 volts in calibrated position. We're going to put the line, we're going to put this so it's right on a line. That's like 2 divisions. And you can see my voice. You can see my voice. Oh, that's very reassuring. Okay, so we got 10 volts. We got 10 volts peak to peak. Hey, that sounds good. 10 volts peak to peak. 5 volts peak. Multiply that by 0.7. You know what? You're right around 4. It's volts. It's not watts, though. That's volts, Jim. That's volts, I tell you, not watts. Oh, if it's volts... So let's just do this again. We've got 2 divisions at 5 volts. 10 volts peak to peak. 5 volts peak. 5 volts peak. That's around 1 watt into 50 ohms. 1 watt. What? Really? You're going to give me 1 watt? I really thought we'd come up with 3.5 watts here, and then I'd be very joyful. How can this be? Do I have to drag another radio in here? Yeah, okay. No reason to stare at that blank screen there. Stare at this blank bench. Perhaps my test leads are no good at that frequency. Maybe. Okay, so let's use. I'm using some Chinese test leads. I'm not knocking Chinese test leads here, but we're going to switch to a Tektronix test lead. What's with you? What's going on here? Can't get the test lead in? Really? This is what it's coming down to. There it goes. Okay. A lot of battle. Wow, I have this feeling I'm still out in the middle of the lake here. Okay, we'll switch this over here. These are automatically times 10 probes. voltage is intended to reduce their influence on the circuit that you're testing. Okay, well, we get exactly the same result or not. What was that? Here we go. So we are now on the 50 volts per division setting. 50 volts. Wow, is that ever different? Is that ever different? So if we accept this, if I go down to 10, right off the scale. So 50, and looks like 30 here, so it's 80. That would be 80 volts peak to peak. So 80 volts peak to peak. I'm going to stop here and do a little calculation. Well, let's see. So I measured 80 volts peak to peak on that scope. I just checked it. That's 40 volts peak. 40 volts peak times 0.7 becomes 28 volts RMS. 28 volts RMS. E squared over R, 28 squared over 50. And the answer is 15. Oh, for crying out loud. How can it be? I thought it was a shoreline I had pulled up to, but apparently it's a false shoreline. I'm still out in the middle of the lake here. Readings all over the place. No apparent way to determine the power output on here. I can't believe it. Oh my gosh. It's just because it's almost 30 megahertz that all these things are happening. I think that's really the cause of it all. 30 megahertz. Such short leads. Now the lead to the scope's not particularly short. It's about maybe around 2 meters long out to here. 2 meters on an 11 meter signal. 2 meters would be approaching a quarter wavelength, wouldn't it? Approaching. There's a cup of coffee waiting for me. I'm going to go talk to it. If you think my bench is crowded, the floor is getting pretty crowded down here too. Look at all those microphones. Just waiting for a radio. Okay, I got another idea. It's just kind of a new version of the same other idea. Using very short cables. That's the back of the radio. That's the back of my meter. Look, it's a short cable. This is really short. And here's the dummy lobe with the resistor in it. This is going nowhere. What are you going to say? I'm almost afraid to push the button. Again, I don't know how accurate this meter is. But now I don't know anything anymore. Okay. Oh, we can't even see it. It's just so difficult to get things lit. That's good. That's good. That'll do it. Okay, man, you're on RF power. 4 watts. Look at that. That's almost dead on 4. Yeah. So now I'm in a situation where I'm getting a result which is what I expect. This is danger, 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 danger. You kind of have a notion of what you expect, and when you get it, you think, okay, everything's working, but maybe not. Now, why would this show 4 now? Well, we're getting now. Hey, you know what? I can feel the ground under my feet. Yes, okay. Given this result, I am now going to put a long cable in here, and we'll test this thing again. Okay, good. It's going to take me a moment to do that. So, even though I'm doing this with a CB radio of questionable value, Everything I'm doing would apply to a ham radio too. Now I decided not to put a super long cable in. I put one in that's probably a little over a meter long. A little over a meter long. Now what do you say, Mr. Meter? Too many meters. Can you see it? It's reading 6 now. 6 watts. And it can't be 6. Well, the lesson, this is a tough lesson I'm learning here. It's similar to the lesson I learned years ago about the capacitance in test leads when I first started attempting to repair FM radios. And all my measurements were just wild. And then, because I just wasn't thinking of it, somebody reminded me that at a high frequency, like 100 megahertz in an FM radio, or even the 10 megahertz, which is only a third of this, you can have effects in your test leads that are upsetting the circuit that you're testing, and you're just never going to get there. So let's put, so I did something close to a quarter wavelength there, interestingly enough. To put the next length of cable on, it's going to take me a couple minutes to get it. Okay, so I was going to use this bundle of cable I have here. It has this kind of connectors on the end of it. It's quite long. I use this a lot when I'm fooling around, say outside with antennas and stuff like that. This cable is RG62. I just found that out, never knew that. RG62 has a characteristic impedance of 92 ohms. Wow, okay, can't use this because it's just introducing another whole issue. So I do have some 50 ohm cable I'm going to have to fetch from the garage, and we'll use that. Okay, here's the long cable I'm going to try. This cable's very stiff. It's not going to bend well. And it says on it, we turn it around, it says CGI signal wave part number, has a part number, 50 ohm 400, 50 ohm, you can't read it anyway, 50 ohm 400 series cable. 400 series cable. 50 ohm, that's the magic word. You know, I've been fooling around with this stuff for so many decades. And if you ask me what makes it 50 ohms, I couldn't really explain that. It's the characteristic impedance of the cable. I can make those statements. Okay, so I'm going to put this in here where the dummy load was. Oh my gosh, this is going to send this meter flying. Now, I'm going to have to measure this too. And I'm going to play it out so it's not in a coil. Yeah, stiff cables. Don't use stiff cables. Okay, let me get this set up. It'll take a minute here. Okay, so what I've done is I've left the short cable running from the radio to the meter, and I put the long cable, you can see it coming out the back here, and that cable goes all the way. There's another piece of it there, that coil's not involved, out to there. That I measured at 24 feet. I'm willing to bet it's actually 25 feet of cable. That's my guess. It's around that length anyway. Okay, everything's tangled up here. There we go. Okay, you can kind of see the meter there. Oh, you crazy, crazy camera. If I do this. There. Now you can see the... There we go. What do you say? So now the meter reads a little under 2 watts, just for fun. What happens if we try to use the SWR now? You know, can this possibly work when even, like, I can't get it to calibrate all the way up? SWR here is pretty bad, according to this. Now, I think really the situation here is these meters will read correctly under certain conditions. And those conditions are kept quiet by the people selling these meters and all that kind of stuff. And in order to get a grip on this, you have to do the kind of stuff I'm doing, which means you need multiple meters, you need all this equipment to gain insight on it. And generally what happens is somebody buys a CB radio, they buy a meter like this, they buy some cable, they buy an antenna, they screw it all together, and whatever it says is just fine by them. That was me when I was a teenager, and I had a CB radio. I had a meter. I don't think it was this one. Was it this one? Could even be this one. And one of the things I noticed, I think when I transmitted, my radio would indicate the power output, and the meter would go up and show you what the power output was. Well, it'll give you some number anyway. But I noticed in my car, when I got up to, back then it was miles per hour, when I got to 60 miles an hour, my whip antenna on the back of the car was bending back quite a bit like this. And I could see the power meter going up and down in relation to the antenna waving back and forth. And I wondered, what's that mean? And I think basically what's happening in my shop today is I'm driving my car again now at 100 kilometers an hour, and meters are misbehaving. Of course, I'm not driving a car at 100 kilometers an hour. I'm sticking different lengths of cable in. So I've moved the load to the far end of a 25-foot piece of cable, and the result is this meter is reading about half the power. Now, can that really happen? Can the radio actually reduce its output? Can the radio actually reduce its output? Well, some of these radios have protective circuits in it. And if you do have a bad situation with your antenna, the radio will control its output and reduce it. Now, is that because of some tricky circuitry? Or is that just the fact of the matter? When you have a bad antenna, you have a reflected energy coming back to the radio, and the result of that reflected energy is ultimately the output of the radio gets lower when measured on these meters. I don't know. There's too many. There's too many things in there. Oh my gosh. It's like going to the doctor and he measures your blood pressure and then pronounces 16 different illnesses. Well, wait a minute. Don't you need more tests? Can you figure all that out from one test? Or worse yet, you go there, he checks your blood pressure, you're okay. Thumbs up on you, but meanwhile, you're sick in 16 different ways. Well, I'm going to extend this cable and repeat this test. I'm going to double the length of the cable and repeat this. And why am I going to do that? What else am I going to do? Go drink coffee? Oh, I spent a lot of time looking for a particular connector I cannot find because the connectors on that big cable I'm using, they're not PL259s. Let me show you. I don't even know what the number of this is, but you can look inside there. It's this kind of connector. Now I do have the adapters necessary. I just can't find them. So in the meantime, I'm going to switch to this other 92 ohm cable. Yeah, I'm introducing another variable here. So, but for the sake of doing something. Now on the other end of this cable, which is about 50% longer than the 50 ohm one I just tried, so that would put it in the 40-foot range. I lost track of how long it is. It's anyway, whatever it is. Let's just see what happens. Let's just see what happens here. Dummy load 6. So the length is similar to the 50 ohm cable I just tried. The watt rating is 6. And what if we try this SWR? What in heaven's name does it mean? Oh, baby. Right over. It's going right off scale. Right over. You can't even see the meter burying it. So that's kind of weird too, isn't it? And I have a 50 ohm resistor at the end of this cable. Jeepers, wouldn't this... Shouldn't that do the trick? Now, I'm almost all the way to my actual 102-inch whip antenna lead. I might be able to make it there with a bunch of these cables. And until I find that other connector, I can't really finish off the study I was trying. So let's see if I can make it all the way to the whip antenna. So this would be a weird combination of cables to get there. Weird's okay. Okay, so it's quite a weird combination of cable now. So coming out of the radio, short 50 ohms to this guy. From here, a 92 ohm cable running through my house, where it then connects through SMA connectors to that big 50 ohm stiff cable, and then that then connects through some adapters to a 75 ohm cable, which then runs another, I don't know, 40 feet maybe only 30 feet to a 102-inch whip antenna that has a single radial ground plane running off, just a single ground plane, tuned ground plane. That antenna I have measured using this meter at a SWR of about 1.6. Believe it? I don't believe any of it anymore. I never have, in fact. I never ever have believed this stuff. Well, let's see what we can hear. Maybe we can hear something here now. Squelched out. Let me just, I need to strain relief this cable here. It's going to pull the radio down. Done here. How about that crazy American? How about that crazy American? Can you hear this crazy Canadian? It came up in the normal range. Let's look at that again. So it's showing 3 watts. SWR. Okay, so SWR is 1 to 4 according to this. Believe it? Do you believe any of it? 1 to 4 is pretty bad. They even indicate part of the scale here in red. Kind of warn you that most of your signal is not going out. Okay, well, channel 6 is where the skip guys hang out. The guy you heard is almost certainly in the southern United States, due south from here. So, you know, Alabama, Georgia, down that area. I have heard people from California, lots from Florida on skip. Well, it's interesting. I'm able to receive with this gigantic cable going out to the antenna. I'm not saying I'm receiving all that's there. Could be there's 10 people talking right now we're not hearing. Who's to say? Who's to say? Who's to say I grab my little walkie-talkie here. Quite a ways away from the antenna here. It's the far corner of my property from where I am, kind of. And this is a broken antenna, and most of it's missing. Here it comes. This radio was on channel 14, so if I push it, nothing here, go up to 14, I think it's 14, give her a shot. So, I mean, oh, that's kind of interesting. So, here, this, oh, what's happened to my video? My video is frozen. My hand is stuck in space there. Oh, so these kinds of things where the video freezes happen at times when I'm doing things with a lot of electricity. I mean, like plugging stuff in or what, I don't know. It's easy to correct here. I'll just do this. Reset. And oh. Okay, in this case I probably stepped on the wire. No, I haven't. Uh-oh. Uh-oh, we're going downhill here. Try one more time. Reset. There we are. There we are. Okay. Now, did I blow my camera off with this? I don't know. I didn't notice when it happened. So, I can't tell you. Back to what we're doing now. Back to this. I was playing around with the walkie-talkie, which I've set down. Come on. There it is. There it is. There it is. There it is. Okay, so now what you're going to hear, this is turned down. I turn it right off. Is there anything else that does that? So I'm waving the antenna around. Yeah, this. Yeah, I don't know if I'm really. I think what I'm doing is I'm detecting, leakage off the cable, and it's providing a little bit of signal here. But I don't know if that's really the case. Could be more the lights in my shop that are doing this. No, don't seem to be. Okay, so I'm moving away here. Nothing happening over here. So maybe it is from that cable. But channel 14, there won't be anything happening on channel 14. Unless, when the skip is really rolling, and there's all kinds of guys on channel 6, channel 28, channel 10, channel 11, all these channels, that guys by the galore on it with, I guess they're hyped up CB sets. You can tune to the regular CB or the other CB channels, and occasionally you can pick up two people having a casual conversation. They're only a few miles apart, and they're just doing the usual CB thing they do. They don't realize their signal's coming all the way up to here with a little 4-watt radio when the conditions are right. Okay, what do we do next? I must find that connector, and we must give this a go. 13. 10? Let's go up to 28. Why these particular channels? Who knows? Nobody home. There are differences. I go from the top of the band to the bottom. And he's gone. So, I do get a kick out of listening to Skip. Well, until that connector appears, I cannot do the 50 ohm test. And what am I going to get out of it anyway at this point? That's a really good question. I don't know where I'm going with all this. I'm just finding out incredibly. Yes, exactly. What I'm doing is not credible. It's incredible. I must find that connector, so I'm going to go on another connector hunt. That can only be in like 3 places. How come I can't find it? One of the things I didn't try, and I should try, is transmitting to this walkie-talkie. So I'm going to put this on, turn it up, stick it in another room here, get it away from the radio. I'm not sure if we're going to be able to hear this or not. 14. Ooh, that's feedback. That's feedback all the way from here. That's a shocker. Wow. That's a real shocker. Okay, just turn down the volume a little bit. I think you can hear that. Okay, well, there's no doubt the signal, well, there is a lot of doubt, isn't there? I was going to say, no doubt the signal's making it to the antenna. I don't know that to be the case. It could be radiating off this cable. Walkie-talkie's only a very short distance away. Oh my gosh, all for just one connector. If I could just find this one missing connector, it would be a very happy camper. What I'm going to try now is I'm going to switch radios. We're going to make a kind of an accurate observation here on the meter of how much power. Let's do this, well, we'll leave it on 14. Okay, this power. What does the meter say? It says just over 3 watts. Okay, now we're going to switch to this older guy here. And we're going to see what it says. So all I got to do is just move the connector here. Another reason for my camera freezing earlier is I may have stepped on the camera wire and disturbed the connector. Okay, I've got to turn on another power supply to make this all work. Flip this guy off. He's got no antenna. This guy on. 14. 10, 11, 12, 13, 14. This is 14. The numbers are all messed up here. Hey, why don't you come down? Come down from way up there. Don't come too far. Won't be able to see the meter. Can't really see the meter here. Where's my piece of exposure paper? Not doing the trick. Okay, so a little over 3. There we are. Oh, I've got no microphone plugged in. That's not going to work. Okay, the microphone. Here it is, right here. What are we going to find out now? So this is hooked up to a very powerful power supply. So there's not going to be. This isn't going to be weakened by bad cal. So here's the SWR calibrate setting. We'll put this on RF. Why is this up already? Must be reacting to. Hello. Why do we hear nothing? Have I got an external speaker plugged in? I don't think so. We hear nothing here. Oh, you know what? It must be the microphone I have picked. Shoot. Well, might still be able to hit the transmit with this microphone here. I have not found the real microphone that comes with this radio is somewhere. That's about all I can say about it. There we go. Okay, so on the meter, you can't really see it. It's just under 2 watts. So you got this radio doing just over 3. I think it was just over 3. And this one doing just under 2. Or is it the meter? Or is it the length of cable I used? Or what is it? Wow. Wow is all I can say. I have done some other experiments previously, come to think of it, just on my own in the evening back where I do my actual radio listening. Yeah, I actually do listen to radios now and then. And even those experiments indicated that the location of where you put this makes a big difference. So you can have it at the radio, you can have it at the antenna, or you can have it in between if your cable has a way to separate it, and mine did. And when I put this in between or put it at the radio, I get totally different readings, which is really what started this thing, I guess. I didn't think too much about it other than it's just more nonsense. I've just encountered this the entire time I've been doing this kind of work. Well, maybe we've hit the end of the road here for today. I can't find that connector. I'll probably find it as soon as I finish this video. That's usually how those things work. And then tomorrow, I don't know what I'm going to do. I'm not getting anywhere here at all, because my real aim is to calibrate this meter properly. And I'm nowhere near it. No, I'm nowhere near doing that. Okay, well, thanks a lot for watching. I am going to call it the end here for today. Thanks a lot for watching. Sorry this is all kind of going crazy, but I have to kind of, for my own sake, I have to work my way through this stuff. I've read the books, I went to college, I've got the basic theory in my head, but you can see when you go to apply it. Wow. Okay, thanks for watching. And if you're making comments, just be aware, as a matter of routine, I do not read comments. So if you're trying to help me by putting helpful comments in, I'm not reading them, I'm not seeing them. Poor me. That's what I'll say about that. Good luck. Thanks a lot for watching. And maybe I'll see you on the next video. Bye.